Everyone, welcome to Tutors. So today, episode on our differentiation series, we are going to do partial derivatives. Good. So in partial derivatives, we are going to have a function that the constant function that consists of more than two variables. Okay, that's say more than two variables. I can say two or more variables. Okay, not just one variable. So in the normal derivatives, we have like just a function of x, y equals a function of x, and we just want to do dy dx. But in here, we're not doing d something, so it's not this. You know, this is pronounced dy. Okay, so but now in partial derivative, we don't use this denotation, we use this notation. Not really that different, but a bit different. So this will be called del y del x. Good. Now let's go straight to the point. Now, it's the function looks like this. The function that we apply partial derivatives on looks like this. Z is equal to a function that consists of x comma what y. Good. So before starting, I would like to set some notations down for you. Good. So if when we are trying to um, differentiate partially, very partially. So you are differentiating partially with respect to x. You are making it look as if the other variables are constant, are like constant. Okay. So when you're differentiating partially, that is called partial differentiation. You're not unlike implicit. That is, you can check our previous video for this. The implicit functions is partially. Okay, the implicit function is not partially, like you are differentiating each. That's why you have you differentiate y, you differentiate your x. But in partial derivatives, you are differentiating partially with respect to something. Okay, so you can differentiate, you're differentiating the function, but with respect to one of the variable. Okay, you can refer to x with to y because we have more than one variable. So you are differentiating partially with respect to something. The other variables will what will be constant, will be treated as constant. Don't worry. When we look at questions, you get it right. So notation that you should understand and how they function. So for example, if you are given del z del x, del z del x, you have to find del z del x. It means that what you are going to differentiate z with respect to x, okay, partially, okay, that's the word that's missing, partially with respect to x. Del z del y, you are differentiating z partially with respect to y. Now when we have del square z del x square, means you are differentiating z partially with respect to x twice. Can you see that? You're going to differentiate partially with respect to x. Your first answer, what you get here, you're going to differentiate again, also with respect to x. Okay? So del square z del y square means you're going to differentiate z partially, partially with respect to y twice. Can you see that? So the next one you need to look at is del square z del x del y, del x del y, del x del y. Okay. So this can also be represented as z x, z y, z x x. So they might not give you this kind of notation. You can be given this kind of notation also. Z y y. Now this is z y x. So z y x is represented in this kind of format. Okay, so when you have something like this, or you give z y x, or you give it this, what are they saying? It means that you are differentiating Yeah, means that you're differentiating with respect to x first, then partially with respect to y. Okay, you're differentiating with respect to what? X. So how may I take it that what I take this what I see, okay, from here, I move this way. Can you see? If it's this notation, you are interpreting it in this direction. So this way you're differentiating with respect to first. The next one, you're going to differentiate it with respect to what? Y. Just make your arrow this way. Okay. Now, if it's this one is kind of clear. You are seeing x first, then what? Y. So in this kind of notation, take your arrow this way. So I remember. In this kind of notation, take your arrow this way. So easy and so simple. So differentiate z partially with respect to x first, and then partially with respect to y. Good. So you tell me, what is zx y? What does it mean? Okay, you can comment that in the comment section. And let's square z, then y, then x. Okay, what does this mean? Good. Now let's move into calculation. That's my interest. Good. So I just find del u del x and del u del y when u is equals to 3x squared sine y. 3x squared sine y. Good. Now, let's see this. 3x squared sine y. So let's do del u del x first. So del u del x means this function. We are going to differentiate partially. We are going to differentiate u partially with respect to x. Meaning that y will be treated as what? As a constant. And I told you, what's the measure of a constant? 0. So now, if this looks like two different functions, you want your product true, right? You like two different functions. So it's as if that what you have here now, uh, you can take this as your u dv. Remember I product true. This is my u and this is my v. Okay? So I can say let my u be equals to 3x squared, let my v equals to sine y. Okay? Du becomes, in this case, because I'm differentiating partially with respect to x, it's only x that will get me 6x, will be differentiated normally. But now if I see y, irrespective of I know that differentiation of sine y will give me cos y, I will not do that because I'll treat y as a constant because I'm doing partial differentiation. So if I'm treating y as a constant, what do I get? Sine y will turn to what? 0. Okay? So product is what? U dv plus what? V times the u dx. Okay? So u dv will give me what? 3x squared times 0 give us what? 0 plus what? V du, that's what? 6x sine y. So our answer becomes what? 6x sine y. That's del u del x. Good. Now let's do del u del y. Okay? Now, del u del y means you're going to differentiate this function with respect to y first. So we have 3u, let's say let's u because 3x squared product rule, right? Because they're different functions. V equals to sine y. Good. Which means any function of x you are differentiating in this place, it must turn towards 0 because it's a constant. Use the function of x, which means du will turn towards 0 and dv will turn towards cos y because it's what we're differentiating partially to. So now let's do it. So what is product rule? U times dv dx plus v times du dx. So 3x squared times cos y give us what? 3x squared cos y, okay, plus 0 times what? Sin y. What would that gonna give us total? 3x squared cos y. Thank you. So that's how we differentiate partially. So let's look into another interesting question. So let's find uxy uyy of a function u is equals to s cube y minus sine y. I think that anytime you have this kind of denotation, okay, and not something like this, when you have this kind of denotation, you read your, so that you not be confused about how to, which one you are differentiating first. You pick it, you do arrow this way, okay. But if I have something like this, I take my arrow this way, okay. So this is what I'm doing. Good. So ux means you are going to differentiate this guy with respect to what? X, okay. So del u, this ux means what? Del u del x, okay, which means any function of what? Y will turn to what? 0, okay. Now we have a product rule between x and y here, x cube and y. So product rule, u dv, that's what? S cube times what? 0, okay, plus v du, y times what? Du of this, I mean, what is s cube? The first s cube, we have what? 3s squared. Just apply how I use my u and v, and you get that part. Then we're done with this. Then we'll now move to this. This is not a product rule, it's just a single function. So, but it is a y variable, and we're differentiating partially related to x. So it will be treated as a constant. And what is the differential constant? 0 or minus 0, anyone. So 0 times s cube is 0 plus 3s squared y, okay, plus 0. Answer equals to what? 3s squared y. Good. Now, uxy. Uxy. Uxy means differentiate first. Now I tell you like this, I'm moving this way. Means you went s just go to what? Y, then x. You're going to take it this way. Y first, then x this way. So now let's go to the original function and differentiate y by y first. So if it's by y now, which means anytime I'm differentiating x, even though this looks like product of two different functions, okay? So two variables or functions. Anytime I'm differentiating there, anytime I'm doing the something of a function I'm not differentiating partially to, I'm doing y first, okay? So I'm doing y first, what will I get? So the first thing for me to do this first is that I must first do del u, del y first. Then the answer of this del u, del y, I will now do what? Del u, del x on it. So I'll get what? So del u, del y will give me what? Is my u, is my v. So product tree is what? U dv dx. I'm doing y, abi? So u s cube, I'll still write it like that because it's a constant. I'll still write it like that. Dv dx. So dividing this one gives me differential of y give me what? 1, abi? Plus v du ds. V is what? Y times, I want to differentiate what? X. But am I differentiating partially with respect to x? No. So I'll treat s cube as a constant. So the differential of s cube what? Will be 0 minus sine y. I'm dealing with the y function here, y variable here. So I'll have what? Minus cos y. So my answer will be what? S cube minus cos y. Good. So I've gotten del u del y. Okay. So since I've gotten del u del y is equals to s cube minus cos y. Good. Then I'll now do del u del x on del u del y. This is same thing as saying what? U x y. Okay, u x. Okay, so this gives us, so when we have this, now let's do del u del x on this equation. We have what? Anyway, is s cube, I mean. So in this place, we just get what? 3x what? Square. So simple. Because minus cos y, we're now partially with respect to x. So minus cos y will turn to what? 0. So you have 3x squared. Final answer. And lastly, let's do uyy, which means what? We're going to partially what? Differentiate with respect to y twice. So del u on del u del y on it. So these are our del u del y answer. So let's do with respect to y. So s cube turn to 0, right? Because we're doing with respect to y here. And minus cos y will turn to what? Plus sin y. Why is it plus sin y? Because it's minus there. Differentiate cos y gives you what? Minus sin y. And that turns to what? Plus sin y. Minus times minus plus. Good. We've come to the end of the video. So what to do is that you guys should apply z is equals to es squared plus y squared. It's a kind of tough one. Well, tell me what is zxy zyx of this function. Thank you very much.